So, students, in previous we have already discussed about components of remote sensing. Now, further on, we will discuss that which type of remote sensors are there. There are basically two types of remote sensor. First is active remote sensing and passive remote sensing. Students, now this theory is very important, and yes, every time it is creating confusion that which sensors are remote sensor and which sensors are passive sensors and active sensors, right? Here, I would like to tell you there are two types of sensors, that is active sensors and passive sensors. Now, understand why these two types of sensors are given. Firstly, active sensor means what? It will have the artificial source of energy. Means the sensors which we are preparing in the laboratory, and then that sensors in the rocket, means in the launching vehicle we are sending to the space, and through space they will take the information about the earth feature. Now, it has some characteristics that is known as active and passive. Active means the sensors which are sending, they will only emit the radiations towards the earth feature, and that will detect the properties of earth feature, that is known as active. Now, here I would like to give you an example of, yes, you might know the movie Koi Mil Gaya, the Hrithik Roshan movie. Yes, why I am telling you to correlate that? In that they have shown one alien. What was the capability of alien? You have seen. If the alien gets the sun, he is charged up. He is only charged up when he gets the sun. Then only he has the powers. Similarly, the sensors are made accordingly. But in our case, sensors are two types. That is, one is the active and one is the passive. Here I would firstly discuss about active. What I said, active does not require any extra energy. That satellite itself can send the pulses of energy and which can interact with the target. Remember, active sensors are carried out in all the conditions. They can carry out the process of gaining information in all the conditions, that is day, night, in any weather condition. Right? Now through the image, you can see what you can see. Sun is present, right? And our sensor is also there. You can see the first arrow is sensor sending the information, and the second arrow is what? The information going back to the sensor. But here, sun is not taking any part. So in simple language, I can tell you, you can think of active sensors like a handheld camera with the flash turn on. Means the object itself sending the energy and object itself gaining the energy, and they are taking the information. That is active sensors. According to what information we require, we are making that type of sensors. Yes, generally active sensors are more usually useful because they can work in day and night, and they don't require any extra energy. So active sensors are proved to be good to use. Now, next we are moving further. Next is passive sensors. What is passive remote sensing? See here, the very first image you can see sun is the main source of energy. Till now we have all discussed in component of remote sensing, where I have shown to the pictorial view of a remote sensing process. In all, what? Sun was the main source of energy. So sun is your main source of energy. It is sending the radiation to the earth. Through that radiation, the sensor is capturing the data. See to the image properly, so that will get fixed into your mind and you will not get confused. Because in exam when it is asked, explain passive sensors and active sensors, everybody get confused. Whom requires sun energy, who requires solar energy, who requires the itself energy, so it will get confused. So kindly put attention towards it. Passive means passive requires some other support, and that is the solar energy, which is freely available and which is very commonly used energy. So we are using that energy, and that is what, it depends on the natural source to provide energy, right? So here you can also see the image. You can see the image is the sun and the sensor both are kept, and what happens, sun is sending the radiation, and that radiation, that is called incident radiation, and that incident will go back to whom? To the sensors, right? Similarly, I have shown here the light source is sun, energy is going and it is returning to the sensor again. So this is how passive sensor works. Passive sensors usually use natural source of energy, that is sun. They wouldn't have passive remote sensing if sun is not present. So sun is always required as a source of energy in passive sensors. So active sensors and passive sensors, active does not require any energy. Active itself send the pulses and gather the information, but passive requires what? It requires solar energy to gain the information. So this is active sensors and passive sensors, which is important to understand. Difference should also be known. Okay. Now, next, moving further, we can see how energy interaction with atmosphere. Yes, student, this is very much important. How can it be important? Yes, yeah, I have discussed in component of C. I am making you see here again. See here in components you can see the alphabet A is source, then next is B is what? That is atmospheric interaction. What is that atmospheric interaction technically? Yes, I have already discussed in short that that technique is what? Energy which is transmitted to the source will interact with the atmosphere. It is very obvious that energy which is coming from any source, it is coming from sensor, or it is coming from so sun, any radiation coming from it, it will happen with what? They have to interact with the atmosphere. They have to meet the atmosphere. And atmosphere consists many types of substances. You all know that. And interacting with that, energy should be such a strong that it reaches to our surface and get back stored into the sensor. Yes, that happens, and this energy interaction is very much important. There are a number of particles and gases are present in atmosphere, as we all know that all are present and can be affected by the incoming light sources. Now, the topic energy interaction with atmosphere, understand it has many types of interaction in the atmosphere. First is what? Absorption. Second is scattering, refraction, and reflection. These are the four main types of energy interaction with atmosphere. Yes, explanation can be asked of this. Now, simple, first we will understand from where the image itself. You can see the rays, solar radiation coming from sun having transmission and they are directly reflecting, right? That is reflection. Next is refraction from one medium to other medium. It is changing its direction. And next comes absorption. Absorption means it is absorbing all, means the substance is absorbing all the rays. And last is scattering. Scattering means what? It is scattering in all the direction. They that depend on how is the wavelength, what are the particles present in the atmosphere. Accordingly, it will scatter because every radiation has its own property, and when it interacts with the atmosphere it meets up with the other property, and that is why this type of phenomenon occurs, right? So moving further, we will discuss all these four into detail. Student, remember, you have to explain this energy interaction with atmosphere because it is very important. When we are making such a expensive sensors, then we have to take care of this all interaction with atmosphere, because our sensor is where it is in the space. The rays are coming from sensors, the rays are going back to the sensor. If it is passive, sun will provide the energy to gain the information, but ultimately it has to be stored in the sensor. So again from the atmosphere, from the target to the atmosphere, and again atmosphere to the sensor. So atmosphere consists so much of importance, and that is why we have to make our sensors and radiation should be in such a way that it can not affect much to the radiation and important information can be gathered. So firstly, we will discuss about what? We will discuss about scattering. Scattering. What is scattering? Scattering means we have already discussed when particles are of large size or gas molecules present in the atmosphere, it causes radiation to be redirected from its original position. Means it will deviate from its original position. That is actually scattering. Means it's scattered in haphazard areas. It depends on the wavelength of radiation, the abundance of particle gas present in atmosphere, and distance traveled through the atmosphere. How much distance is traveled, what type of particles and gases are present, depends on that scattering is will taking place. Right? Now, we have to try in such a way that scattering is much more neglected, but it cannot be neglected because many substances, as we discussed, that molecules, water molecules, and the gases, the smoke, everything is present. But how can we minimize it? Yes, there are many ways to minimize it. Firstly, we will discuss there are majorly four types of scattering, but we will here discuss three types. There are four types, that is relay scattering, Mie scattering, Raman scattering, and non-selective. But Raman and Mie scattering are same itself. So here we are going to discuss three main types. Student, remember, you have to remember these are much more going detail into the physics, but yes, this is important. So you have to remember because these characteristics will be very helpful to the sensors, and according to that we are making our sensors. How sensors are made, further on we are going to study. So first of all, relay scattering. What is relay scattering? It occurs when particles are very small compared to the wavelength of the radiation. They could be particles such as small speck of dust or nitrogen or oxygen molecule. Right? It causes shorter wavelength of energy to be scattered much more than longer wavelength. Yes. So shorter wavelength will always be affected by whom? Relay scattering. Because of whom? Small speck of dust, nitrogen and oxygen molecules. So we need to do what? It is almost on the upper portion of atmosphere. Means as soon as the wavelength enter into the atmosphere, it will be scattered by the relay. If it is having shorter wavelength, then scattering will be much more. Further on, we will discuss other process. Thank you, students.